We will now solve problems using the concepts in projectile motion we described so far. Well, let's start by looking at some of the equations and relations that are important for problem solving. The first thing to do is to identify the initial velocity of projection v0 and the angle of projection theta. The second thing to do is obtain the x component of the velocity, that is v0 cos theta, and the initial y component of the velocity v0 sin theta. Now, the x component does not change. The y component of the velocity will decrease, reaches a zero at the top point, and then decreases. Third, the x position and the y position. Alright, do you know what the x position is equal to? What is the equation for the x position? Since the x velocity remains a constant, the x position will be the x velocity multiplied by the time of flight. So the x position is v0 cos theta t. The y position is v0 sin theta t minus 1/2 gt squared. The horizontal and vertical velocity of the projectile at any given time. Well, the horizontal velocity does not change. How does the vertical velocity change? The vertical velocity Vy equal to Vy0 minus gt. So Vx equal to Vx0, that will not change. Vy equal to Vy0 minus gt, which is Vy0 is V0 sin theta. So Vy equal to V0 sin theta minus gt. Once you have these relations, you can actually solve any problems in projectile. Alright, let's look at a problem. An artillery shell is fired with an initial velocity of 100 meters per second at an angle of 30 degrees above the horizontal. Find A, its position after 8 seconds. Well, its position after 8 seconds will have an x value and a y value. We need to find both. First of all, pick our data. The velocity of projection is 100 meters per second and the angle of projection is 30 degrees. We need to find the x position and the y position after the time t equal to 8 seconds. Well, what is the x component of the velocity? V sub x equal to 100 cos 30 degrees, which is 86.6 meters per second. Vy0, initial vertical velocity, is V0 sin theta, 100 sin 30 degrees, and that is 50 meters per second. Okay. The x position is the x velocity multiplied by time, v0 cos theta multiplied by time, and the x velocity is 86.6, which doesn't change. The time is 8 seconds, so that will be 86.6 multiplied by 8, that is 692.8 meters. And what is the equation for the y position? The y position is v0 sin theta t minus 1/2 gt squared. Vy0 t minus 1/2 gt squared. And Vy0 is v0 sin theta, and you know it is 50 meters per second. So this will be 50 times 8 minus 1/2, g is 9.8, multiplied by 8 squared, the time equal to 8 seconds. And that is 86.4 meter. And so, what is its position after 8 seconds? Its position is 692.8 meter I plus 86.4 meter J. Is that right? Okay. So, in other words, we should be able to write the position at that time as R equal to 692.8 I plus 86.4 J. The position at that particular given time. Alright, let's now do the B part. Find its velocity after 8 seconds. Alright, the velocity after 8 seconds will also have a horizontal component and a vertical component. Well, the horizontal component of the velocity will not change. That will be 86.6 meter per second. How does the vertical velocity change? Vy equal to Vy0 minus gt. So Vy equal to Vy0 minus gt. Vy0, the initial vertical velocity, is 50 meter per second. So that will be 50 minus 9.8 times 8. That is negative 28.4 meter per second. So that is the time the projectile is on its downward journey. The vertical velocity at that time is negative 28.4 meter per second. So how do you now write the velocity? The velocity has an x component, 86.6 meter per second, and a y component, negative 28.4 meter per second. And so this is the velocity of the projectile at that time. We need to find the magnitude and the angle of the velocity. The magnitude is the length of this vector. What is the length of this vector? It will be square root of Vx squared plus Vy squared. So V equal to, the magnitude of V equal to square root of Vx squared plus Vy squared. Vx is 86.6, Vy is negative 28.4, and so that will be square root of 86.6 squared plus 28.4 squared. That is 91.1 meter per second. Well, we also need to find the angle. What is the angle here? If this is the angle theta, tangent of that angle theta will be Vy divided by Vx. Right? So tan theta is Vy divided by Vx, which is 50 divided by, is it 50? No, it will be negative 28.4 divided by 86.6. Is that right? Tan theta is negative 28.4 divided by 86.6. And therefore theta equal to tan inverse of that quantity. Now remember, this is a fourth quadrant angle. Is that right? X is positive, Y is negative. That is a fourth quadrant angle, and the calculator will give it to you directly. If you put this in the calculator gives you negative 37.8 degrees. The velocity of that projectile at that time, at t equal to 8 seconds, is 91.1 meter per second at an angle negative 37.8 degrees with the positive x-axis. Alright. Part C. What is the time required to reach its maximum height? What is the time required to reach its maximum height? Now, we discussed that in our previous lesson. Now, what is the significance of the maximum height. You know, the vertical velocity, that is v0 sine theta, will decrease and will become 0 at the top point. v0 sine theta is the initial vertical velocity that will decrease and will become 0 at the highest point. And so, in order to find the time taken to reach the maximum height, what all we need to do is write down the vertical velocity equation. What is the equation for the vertical velocity? Vy equal to Vy0 minus gt, which is v0 sine theta minus gt. And at the maximum height, what will be the value of that vertical velocity? Will be 0. So we set that equal to 0 and solve for t. That's all we need to do. Vy equal to Vy0 minus gt. Now, when the shell reaches its maximum height, Vy equal to 0. That means we set this equal to 0. That is 0 equal to Vy0 minus gt. And therefore, t equal to Vy0 divided by g. And Vy0 we had calculated early is 50 meter per second. Therefore, that time is 50 meter per second divided by 9.8 meter per second squared. That is 5.1 second. Well, can you tell me now, if the time taken to reach the maximum height is 5.1 second, what is the time of flight of that shell? The time of flight will be double that time. The time taken to reach the maximum height is equal to the time taken to return to the same horizontal level. Alright, we will use that in our next section. What is the horizontal range of the shell? The horizontal range. Now, the horizontal range is the horizontal distance traveled by the shell, which is the horizontal velocity multiplied by the time of flight. And what is the horizontal velocity? This is the horizontal velocity, Vx equal to 100 cos 30 degrees, and you know its value. If you multiply this with the time of flight, what is the time of flight? Well, if the time taken to reach the maximum height is 5.1 second, then the time of flight is double that time, which is 10.2 seconds. There you are. The time of flight is 10.2 seconds. Therefore, x equal to Vx multiplied by t, and Vx is 86.6 multiplied by the time of flight is 883.7 meter. And that is the horizontal range of that shell. Well, this is a representative problem. We discussed practically every aspect of projectile motion in this problem. Let's now look at another problem. A plastic ball